Hello and welcome students. My name is Shampa. Today we are going to study laws of exponents. So let's begin. The first law of exponent. Well, it states that if we have a as a rational number, if a is a rational number and p is an integer, then if we add a, which is again the same rational number, and q is an integer, in this case, p and q are exponents. So let's start again. If a is a rational number and p and q are integers and we are multiplying them, in that case, we will keep the base same. A is the base. So we will keep it same and we will simply add the integers. The condition here is a should be a non-zero rational number. So let us understand it with the help of an example. Let's say we have 2 raised to the power 2. Let's multiply it with 2 raised to the power 5. Now, what we normally do is this. We will write 2 raised to the power 2 like this, and we will write 2 raised to the power 5 like this. So this is 2 raised to the power 2 and this is 2 raised to the power 5. So now what we do? We count the number of times 2 has been multiplied. So we can see it has been multiplied 7 times. So the answer is going to be 2 raised to the power 7. Now look at this exponent 7. This is actually the sum of 2 and 5. So we can safely say whenever the bases are same and we multiply two exponents, we add their powers. Whenever the bases are same and we multiply two exponents, we simply add their powers like this. So this is the first law of exponents. Let's move on to the second law of exponents. I'm sorry, there was a small error in the sentence. We don't multiply exponents whenever we multiply two rational numbers with exponents and the two rational numbers have the same base, we add up the exponents. Now let's understand the second law of exponents. Let's say we have 7 to the power 5 and we divide 7 to the power 5 by 7 to the power 3. So what we normally do is we write 7 5 times. This is what we do. And we divide it by 7 to the power 3. So in the denominator we will write 7 3 times. This 7 will cancel out this 7 will cancel out with this 7 will cancel out with this 7, and eventually we are left behind with 7 to the power 2. So now look at this exponent 2. This is actually a difference of this exponent and this exponent. So we can safely say the second law of exponents state that whenever the bases are same, we subtract the exponents. I'm sorry, let me rephrase myself again. Whenever the bases are same and we divide two numbers with exponents, whenever the bases are same and we divide two numbers, we subtract the exponents. Let's understand it with one more example. Let's say we have 2 to the power 7. Let's divide it by 2 to the power 4. So we have 2 to the power 7 minus 4, which is 2 to the power 3. You can verify it like this. You can write 2 in the numerator, 2, 3, 4, 5, 6, 7. 7 times, and in the denominator, you can write it 4 times like this, and eventually we are left behind with 2 raised to the power 3. So the first law states whenever we multiply two numbers with same base, we add the exponents. And whenever we divide two numbers with same base, we subtract the exponents. Let's move on to the third law of exponents. Now, before we move on to the third law of exponents, let's clarify one more point. Now, let's say we have 3 to the power 4 and we divide it by 3 to the power 4. What's going to be the result? According to the second law, we keep the base unchanged and we subtract the exponents. So this is going to be 3 raised to the power 0. But what is the value of 3 raised to the power 0? I say it is 1. Would you believe me? Don't believe me? I'll prove it. We can write 3 raised to the power 4 like this. And we are going to divide it by 3 raised to the power 4. So they will cancel out each other and we are left behind with 1. So this proves the point that whenever the bases are same and the exponents are also the same and we divide two numbers, the result we get is the base raised to the power 0 and it is equal to 1. So we can conclude that anything raised to the power 0 is always 1. So let's move on. Now let us understand the third law of exponents. Say we have a number 2 raised to the power 3 and we put it in the bracket and we put another exponent here. What are we to do in this case? We would write it like this: 2 to the power 3 into 2 to the power 3 into 2 to the power 3 into 2 to the power 3. So this would turn out to be, the base will remain the same and we have the sign of multiplication. So we will add up the exponents. This will turn out to be 2 raised to the power 12. Now pay attention to this exponent part. Isn't it a product of this and this? Yes, it is. So we can safely say whenever we have a base and there's an exponent and there is one more exponent outside it, we simply multiply the exponents. We multiplied 3 with 4 here. Let's take one more example. We have minus 3 raised to the power 5 raised to the power 3. So the third law states that whenever there is an exponent over an exponent, we simply multiply the exponents. So this is going to be minus 3 raised to the power 15. Now let's move on to the fourth law of exponents. Well, it says whenever we have two non-zero rational numbers they may be different. Say we have A and we have B. We have two non-zero rational numbers. They are both non-zero rational numbers and the exponents are the same. Let's say m here and m here, and we are multiplying them. In that case, we will multiply them as usual and we will put them in a bracket and they will have the same exponent as the exponent of their products. Let's understand it with the help of an example. We have 2 raised to the power 5 into 3 raised to the power 5. So in this case, we have different bases but the exponents are same. So we will put the bases under the bracket and we will take the exponent outside, and this will be the exponent of the product of the bases. So the fourth law states that whenever there are two non-zero rational numbers with same exponents and we multiply them, we take the exponent as a common exponent of their product. Let's understand it with the help of one more example. Say so here we will first solve it as usual and then we will verify the result after solving it with the help of the fourth law of exponents. So minus 4 raised to the power 2 is 16. 3 raised to the power 2 is 9. So it's 144. And let's solve it with the help of the fourth law. Minus 4 raised to the power 2 into 3 raised to the power 2. So here we have minus 4 into 3 inside the bracket. And the exponent, which is the same in both the cases, will be the exponent of their product. So this is going to be minus 12 raised to the power 4, and it's going to be, I'm sorry, minus 12 raised to the power 2, and it's going to be 144. They are the same. Let's move on to the fifth law of exponents. In the fourth law of exponents, we multiplied two non-zero rational numbers. Their bases may or may not be different, but the exponents were the same. In that case, we multiplied the bases and we took out exponent as a common exponent of their products. Now, what if we divide two rational numbers? Say we have 5 to the power 3 and we have 7 to the power 3. Here we have 5 and 7, and 5 has the same exponent, so is 7. In that case, their quotient will share the same exponent, that is 3. This is the fifth law of exponents. Let's understand it with the help of one more example. Say minus 2 by 7 raised to the power 5. This is going to be, this exponent 5 will be shared by minus 2 as well as by 7. So the result is going to be minus 32 by 16,807. So the fifth law states whenever we have a rational number where the numerator and the denominator share the same exponent, in that case, we can put the rational number inside a bracket and the exponent will be the common exponent of both of them. Let's make the concept clear with the help of one more example. Let's say we have 2 raised to the power 3 and we have 4 raised to the power 3. Let's make it a bit simple. We can write it like this: 2 by 4 whole raised to the power 3. Now, this will simplify our life. We can cancel out 2 in the numerator with 4 in the denominator. This will become 1 by 2 raised to the power 3, which is actually 1 by 8. So it was easy. Even otherwise, if you have solved it without using this law, it would be 2 raised to the power 3 is 8 and 4 raised to the power 3 is 64. See, they are the same. So that's it for today's session on exponents. See you in my next session where we will discuss some problems based on exponents. Till then, please take care of yourself and have a good day.